ME 8691 Computer Aided Design and Manufacturing Unit 1 Introduction to CAD. Topic is 2D transformation. So the geometrical transformation which an image can be represented in enlarge, reduce, rotate, or we can move the geometric objects. These changes by using the coordinate changing, we can change the pictures or new set of values depending upon the requirements. The basic transformation which are used in the geometrical transformation are translation, scaling, rotation, reflection, and shear. Before going to transformation, we need to know what or how the point has to be represented. For example, see the drawing here, point and line representation, how a point should be represented, how a line should be represented in the diagram. For example, a point P is a component of x and y. A point P is a component of x and y. Then the line is the interconnection between P1 and P2. See the drawing. The line is a connection of 2 points, which is P1 and P2. The P1 contains x1 and y1 and P2 contains x2 and y2. So line contains, it is the interconnection between P1 and P2. So that will be equal to x1 and x2, comma y1 and y2. Next, the point and line can be represented in two forms. One is Cartesian coordinate system and another one is polar coordinate system. In Cartesian coordinate system, there will be in four forms: first quadrant, second quadrant, third quadrant, and fourth quadrant. So depending upon the values, the points can be marked. But in polar coordinate system, it can be represented in the form of trigonometrical form, which is used by cos theta and sin theta. Here the origin point is O, this is the x direction, and this is the angle theta, angle of the line theta. So which is the from origin to, from O to P, it is called as radius, and O to Y it is called as x. So P is a function of r comma theta. So P is a point which is represented by r, radius, and angle of inclination theta. So the polar coordinate system, x is represented by r cos theta and y is represented by r sin theta. So the polar coordinate system, which is represented by x square plus y square equal to r square. Before going to system, we need to know the Cartesian coordinate system and polar coordinate system. What is the main difference between these systems? The Cartesian system is a normal coordinate system which has 4 quadrants. Depending upon the value of the system, we can mark the point. Here the x value is in the positive sense, so x plus. Here the y point is y plus. Here it is in the negative direction. So because the O is the origin point, x minus, and this point is y minus. Depending upon the value of the point, we can mark it easily and get the point. Next is the polar coordinate system. The polar coordinate system is represented by a point P, which is in the form of r and theta. R is the radius of the line and theta is the angle of inclination of the point. So P is represented in the form of r comma theta. So the normal x component is defined by r cos theta, and vertical component y is represented by r sin theta. Then the final equation is x square plus y square equal to r square. So the basic transformations are, the basic important transformations are translation, scaling, rotation, reflection and shear. Let us see by one. What is translation, what is scaling and rotation and all. The first topic is 2D translation. Let us consider the point P, which is translated along x and y axis by delta x and delta y respectively to a new position. The new coordinates after transformation is given by the old point P is points of x comma y. Then the new coordinate points are P dash. The new coordinate point of the point is P dash, which is the component of x dash and y dash. So the x dash is the function of x plus delta x and y dash is the function of y plus delta y. So the final point P dash is represented by x dash comma y dash. P dash is a component of x dash and y dash. So the x dash is defined by x plus delta x and y dash is represented by y plus delta y. Here with this drawing we can easily know what exactly the translation is. Here it is the origin point. We have two axes x and y. We have x and vertical component y. In this x and y component, which need to move on to the new point, which is x dash and y dash. Here we are going to translate the point based on the origin. So based on the origin, we need to move x and y direction to some value. So the origin x and y, this point can be translated here. So the new points can be represented by p dash, x dash and y dash, z dash. Here tx, that is transformation along the x direction is 4 units and transformation along the y direction is 2 units. So the transformation matrix can be represented by tx and ty, that is 4 comma 2. The translation matrix is 4 comma 2. So next we need to find out the new points, that is old point plus translation matrix. That the old points are represented by 1, 1, 3, 3 and 4, 1 plus the translation matrix is 4 comma 2. So 1 plus 4 is 5, 1 plus 2 is 3, 3 plus 4 is 7 and 3 plus 2 is 5, 4 plus 4 is 8, 1 plus 2 is 3. This is the new coordinate points of the translation matrix. So the points, the triangle has 3 points A, B and C. So the A point is 1 comma 1, B point is 3 comma 3 and C point is 4 comma 1. The translation matrix along the x direction is 4 and translation matrix along the x direction is, y direction is 2. So here 1 comma 1. One is first point is x point and the second point is y point. X is adding with 4 and y is adding with 2. So 1 plus 4 is 5 and 1 plus 2 is 3. So this point is of translation point of A is 5 comma 3. Similarly, we need to find out B dash and C dash. This is the translation of a geometric element. Next transformation matrix is scaling matrix. Scaling is the transformation to change the model in a increasing size or decreasing size, which is called as scaling. If the scaling value is equal to 1, the actual size can be obtained. If the scaling value is less than 1, the size will be low. If the scaling factor is greater than 1, the drawing size will be high. So the new scaling point P dash is represented by S of x, that is scaling at x direction. Sy is the scaling at y direction. Sx 0 0 Sy into x comma y. Ts. Ts is the translation along scaling. Sx 0 0 Sy. Then the new point P dash is Ts into P. From this drawing, we can easily identify what is scaling. Here the point is 1, 1, 4, 1, 4, 5 and 1, 5, which has the scaling value of in x direction Sx is 4 and Sy is 3. So we need to scale in x direction as 4 units and y direction in 3 units. So here the rectangle is there. The initial point, the rectangle has 4 points, 1, 1, 4, 1, 4, 5 and 1, 5. That is the original rectangle. After scaling the points in x direction 4 units and y direction 3 units, the final points can be arrived as 1 plus 4 is 5, 1 plus 3 is 4. Similarly, we need to find out those points A, B, C and D. This is the 2D translation of an object with respect to the x and y axis. See, this transformation alters the size of the object. The scaling transformation alters the size of the object, which I already told. The scaling occurs about the region. The scaling process which occurs at the origin point, that the point is represented by x comma y. After scaling point, the p dash is denoted by p into s. S is the scaling factor. Then the p dash is a function of x dash and y dash. That is a combination of points x dash and y dash, that is equal to x into y into Sx 0 0 Sy. Sx means scalar factor in x direction, Sy is scalar factor in y direction. For example, the initial point is 1, 1, 2, 1 and 1, 2. This triangular points can be scaled into 2 units in x direction and 2 units in y direction. Find out the final points. Let us discuss the point 1, 1 is A. Next is 2, 1 and third point is 1, 2. We need to scale up into 2 units in x direction and 2 units in y direction. So now the final point of A is 2 plus 1 is 3 and 1 plus 2 is 3. So 3, 3. Sorry, 1, 1 row wise, 2, 0 column wise. We need to multiply it. 1, 2 is 2 and 1, 0 is 0. Here 2, 2 is 4 and 1, 0 is 0. Similarly, we need to find out all the points. The final points can be represented by 2, 2, 4, 2 and 2, 4. So the final points after translating the point is 2, 2, 4, 2 and 2, 4. Next geometrical transformation is rotation. If the transformation and variation of the object can be rotated in a counterclockwise direction or clockwise direction about the origin. About the origin, the geometrical entity has rotated in the clockwise direction or counterclockwise direction. By creating the entity once, then it rotating or copying about its circumference. So the point is represented by x, y. So the point is r cos theta and y r sin theta. because the x direction is represented in cos theta because it is a horizontal component, and y component is a vertical component, so it can be represented in r sin theta. After rotation, p dash that will be equal to x dash and y dash, which is r cos theta plus phi, then r sin theta plus phi. So the final point p dash is x cos theta minus y sin theta, x sin theta plus y sin theta. So the rotational matrix can be arrived cos theta sin theta minus sin theta cos theta. So the final translation point can be found out by p dash equal to p into r. R is the rotational matrix and p is the initial point of the line, or maybe any object. So the rotational matrix cos theta sin theta minus sin theta cos theta. Then the next translation is reflection. Reflection is same as obtaining. Reflection is the same image which can be appeared in the screen, which is in the mirror image of the original shape. Reflection is the mirror image of the original shape. In most engineering products, the maximum products are symmetrical products. That symmetrical products can be easily done by the reflection process. For example, see this first diagram, reflection about y-axis. This is a two axis, x and y. This object is reflected about our y-axis. So the mirror image of an object, rotate about the object and see what is the final object of after reflection. So the reflection matrix will be minus 1, 0, 0 and 1. Where the reflection occurs, we have to put minus 1 for that side. Here, reflection about x-axis. The component is reflected about the x-axis, so it is coming down, so we need to put minus 1 for the component 1, 0, 0 and minus 1. Next, reflection about the line y equal to x, that is inclined line, that is inclined axis, we need to reflect the object. So 0, 1, 1, 0. There is no minus sign because it is an inclined plane. Next is, fourth option is reflected about y equal to minus x. Reflection about y equal to minus x. So the x coordinate and y coordinate, the origins will be changed. So minus 1, minus 1. So the matrix becomes 0, minus 1, minus 1, 0. Next, the reflection about x-axis and y-axis. The reflection will be in x and y direction. So minus 1, 0, 0, minus 1. Next is shearing. Shearing geometric transformation. This transformation causes the image into slant. Shearing means image to be in a slanting form. That y shear preserve x coordinate and x shear preserve y coordinate. What is shearing? Y shear preserve x coordinate but shift y value. X shear preserve y coordinate but shift x value. For example, the point P is x comma y. After x shearing, the point is P dash equal to P into SH. That is x dash y dash equal to x comma y into 1, 0, B, 1. This is after shearing. Next, the point contains P is x comma y. After y shearing, the P dash is P into SH. X dash into y, x dash comma y dash equal to x comma y 1, A, 0, 1. X shearing means it shifts the x value and y shearing means it shifts the y value. Then the 3D transformation. Before we see about 2D translation, now we are going to see about the 3D transformation. The transformation matrix will almost the same, which is in the 2 cross 2 form. In 3D transformation, the transformation will be in a 3 cross 3 matrix. That first one is 3D transformation. Because it is a 3-dimensional object should be represented in a 3D transformation form. The 3D transformation matrix are developed from the 2-dimensional matrix, which is extended to 3D. That 2D objects can be extended to 3D objects. Here, the 3D translation matrix can be represented by 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. First, we need to see 3 cross 3 matrix. The diagonals are 1 and other values are 0. Then we need to put delta x, delta y and delta z, and finally 1. So delta x, delta y and delta z explain the distance of translation along x, y and z directions. In 2D transformation, the transformation will be in xy direction. Since it is a 3D transformation, so the transformation will be done in x, y and z directions. Next, 3D scaling object. The scaling factors is defined by first taking 3 cross 3 matrix. The diagonals is Sx, Sy and Sz. Then other objects are 0 except the final diagonal as 1. So Sx, Sy and Sz represent the scaling factor along the x, y and z directions. Then 3D transformation. The 3D transformation is begin with the form of 2D transformation. The 2D transformation rotational matrix is defined by cos theta, sin theta, cos theta, which we already know about this 2D rotation matrix. Cos theta, sin theta and minus sin theta, cos theta. After this, we need to put 0 for these elements and the diagonal elements as 1 and other objects as 0. This is the 3D rotational matrix. So the rotational about x-axis. Rotational about x-axis means the starting diagonal and the ending diagonal is with 1 and the midpoints of the matrix is cos theta, minus sin theta and sin theta, cos theta. If the rotation about x-axis by angle theta, that is Ry. Rotational about y-axis cos theta 0, sin theta 0, 1, 0, sin theta 0, cos theta and last diagonal element as 1. So this is the 2D and 3D transformation. 3D transformation are derived from the 2-dimensional matrix, which is an extension of 2-dimensional objects, are called as 3-dimensional objects. So the 2D transformation, the most important basic transformations are 2D translation, scaling, rotation, reflection or mirror and shear. Thank you.